We've seen how important the table structure is to the efficient operation of the database. What's also very important is how we choose to store that data within the tables. MySQL Database system provides many different data storage types for our use, and we need to understand the differences between those types so that we can make informed decisions about how to store our data. The general categories of data are collections of characters or strings, numeric data, and another very important data type within the database, dates and times. There are many different string storage types provided by the MySQL system. We can store characters using the char type. This is a fixed length type whose size must be defined and cannot be exceeded in the table. A varchar is a variable length character with a maximum defined size. We also have text types, tiny text, text, medium text, long text, and binary large object types. Now, when would we choose one type over the other for storing a string? Char type is a fixed length data storage structure. Each character in a string is represented by a single storage byte. So when we declare a char of size 15, we will use 15 bytes of storage regardless of how much actual data is stored within the char type. So this can be inefficient for storing string types with variable lengths. In contrast, the varchar can be defined with a maximum length. However, it adjusts its storage utilization based on the size of the string that's stored within that varchar type. So in our example, the string Bob, B-O-B, would only use 3 bytes of storage for those 3 characters. It's a sharp contrast to storing Bob in a char 15, where only 3 bytes of storage are actually used for the data, but the column data type is declared to use 15 bytes of fixed storage, so there would be 12 bytes of wasted storage. Again, in a large database, this kind of inefficient storage adds up quickly. Now, there is overhead in the use of the varchar type because the system must keep track of what's being stored within that type. So there is overhead associated with the varchar type, something around 1 to 2 bytes of overhead. Again, there are trade-offs for the use of the varchar versus the char type. We'll reduce disk space utilization because the varchar will adjust itself based on the length of the contents. However, manipulating the contents of a varchar becomes problematic because we don't know how much data is actually stored within it. Whereas if we used a char type of fixed length, then we could do any kind of string manipulation against that fixed length storage structure. Experiments have shown that index searches are about 20% faster on a char type versus a varchar type. So this again is very important to keep in mind, that a simple decision such as what type of data storage am I going to use for a string will significantly impact the performance of the database. And we start adding these performance hits up cumulatively, we can significantly impact the performance of the database. Bad table design, poor choice of data types, and other factors that we're going to investigate as we move forward can yield amazingly poor performance in the database. Now, for date types, which are amazingly common in a database and are used very frequently for range searches, we have 5 different storage options. A date type, which simply stores the year, month, and day, a date time, which stores both the year, month, day, and the hour, minutes, seconds, a timestamp, a time, and a year value. Notice the permitted values for these data types and their storage requirements. So let's go look at some code.